Okay, I want to show the importance of having the proper run cap value on that run cap phase of a rotovertor. Okay, right now I have a 2 UF cap only on the run cap phase from L2 to L3. And I have 120 volts across the run cap phase, and I have 70 milliamps in current circulating. This is not watts, this is watts circulating in the run cap phase. You can call it VARS, V-A-R-S. And also, now at this point, with the improper, incorrect, not the perfect run cap UF value, it has 90 milliamp draw. Okay? Now, when I hook this up to here, it's going to add 1 and 0.5, and then this will equal 3.5 run cap. 3.5 UF run cap, which is, I already know, it's like the perfect one because it lowers the draw and everything, just perfect. It changes its tone to a real nice tone. Taking it from 2 to 3.5 makes the draw go down to 20 milliamps. Used to be 90, so that's like over 4 times less. Now look, it used to be 70 milliamps, now it's 200 milliamps of current circulating, and the voltage has gone up to 159 volts AC across there. So you see the difference when you got to really nail that run cap to make these things work good. Okay, I want to do another test with a transformer that is very interesting, so hold on a little bit. I'm going to put this on pause. Okay, I'm going to take this transformer. It's an isolation transformer. It's Stancor, G-I-S-T, and I think that's a 150 or it might be a 130, but here's the specs on it. And it looks like it's not only an isolation transformer, but it steps down from 220 to 120. I'm going to guess so, because the impedance of one side is 9.9, the impedance of the other is 3.5. Okay, so what I did is in series on line 2, here's line 2, see it splits. One of it goes to the power input, and one of it, I have the ammeter hooked up right now, but the other one goes to the run cap, the other side of the run cap. And the other side of the run cap is L3. This is the very basic rotoverter circuit. You put between L2 and L3, you put a run cap, okay? And L1 is, I also have an ammeter on this, but L1 is the power input coming in, AC, from the grid or the inverter or whatever. And L2 is also the power input coming in from the grid or an inverter or whatever, but L2 has also a line going to the run cap. Okay, so that's the rotoverter basic circuit. You could have no run cap at all, and it'll still run. but the draw is going to be pretty high, and actually it might even overheat. So you want to have a run cap on it for good performance, let's call it that. So right now, okay, so I have the run cap, and this is what's circulating, and this is what the volts is. Okay, so I just showed you that. Now what I'm going to do is hook up the 3.5 ohm side of this stand core transformer. Also, I looked on eBay this afternoon, and there's about 4 or 5 of these. Look up stand core isolation transformer, and there's some other brands, and they're probably pretty much the same if you look at 240 to 110 step down isolation transformer. But anyways, I'm going to take off some things and hook this up in series. So I want to show you something. Sorry I'm taking so long. Okay, 1 minute. Okay, the 3.5 ohm side is now in series. You can follow the green wires. Here's the L2 line. Goes into it, comes out of it. I think this is called to have a transformer Inverter, V-E-C-T-O-R configuration, because it is in series to an AC line. You know, the AC is going like this, and it's in series. It's not like this way and this way in parallel like you normally hook up a transformer. You have this transformer in series on the L2 line. Now, this is what is super interesting, and if you see this, you might go, hey, this might even have a chance of looping itself when you see this. Okay, watch. Right now, with this not connected, this is the other side of the transformer, the 9.9 ohm, the step-up side. And it's open. See, nothing. And look at the draw now. That is ridiculous draw. 330 milliamps and 120 volts coming into this thing. Okay? I have a 3.5 UF run cap. All I've done is put this in series on the L2 line. Sorry I'm repeating myself, but now watch this. Also, what we have on the run cap phase with a voltmeter across the run cap phase is 20 volts in there now. Remember, it used to be 157. Now it's gone all the way down to 20 volts by putting this in series on the L2 line, and the draw has gone way up. So if you got to this point of experimenting with transformers, you'd go, this is never going to work, because it raises the draw so much and it takes away all the power. Okay, but look at this, short it out. Take this, see, I have now shorted out this side of the transformer. Now the voltage in the run cap phase has gone down to 11.3, but that's not what's important. Look at what the draw, there you go. See, it's just made the draw go up a little bit, slightly. And we have a shorted out condition over here. That means something low impedance, heavy resistance would resemble that, this shorted out condition. So that means you can put something over here with some good power and you're going to have really low draw. So isn't that nice? So, you know, I don't know what this is, but let's just take a look right now, as long as we're goofing around. Put my ammeter on 20 amps AC, and instead of shorting it out with this yellow wire, I'm going to short it out with an ammeter. I call this crowbarring. Everybody asks me, what's crowbarring mean? This is what crowbarring is. I don't know where I got it. I guess you take a crowbar and you stick it across it. Okay, like short it out. Okay, so now, so that's the amperage we have maximum across this shorted out condition of the other side of the transformer. Okay, so you could say, okay, we got 90 volts coming out, and look at that. See, it's way down there. That's what's important, is it's not affecting the draw. Very little effect. I could maybe goof around with a run cap a little bit, but I'm just going to leave it. Okay, so now you see all that. That's what I think is super interesting. And you get this with a series transformer on the L2 line. The L3 line that goes to the other side of the cap, there's nothing on that. It just goes right from L3 to the cap on the other side. The L2 line has this on it, okay? I think everybody's got that clear. And if you can't understand me in this video, you can click down where you can, they type out what I say in a text. They don't get all the words right, but it's pretty good. Okay, so now let's look at what is coming out of here in voltage right now. We already know it's 90 milliamps. So let's take the voltage off. Put it in voltage AC. Uh-oh. Hold on a minute. Wow, I didn't notice this ever before, but you know, Hector's saying what is going to be charging the battery is going to be radiant energy or RF energy. And perhaps that's exactly what this means here, is when I look at the voltage across this, and it is stepping up. It is being stepped up. It's 380 volts. My God. I've never seen that before. I don't think I've ever looked at it before. I thought this was about 15, but okay, that's what the meter says. If I turn it down to 300, 200, it says low, but you have to turn it to 750. Now you can see this really high voltage coming out of here. Whatever. So, now I'm going to continue on. And the next step is you put a voltage regulator across this thing. Not a voltage regulator, full wave bridge rectifier. Okay? So 1 minute and I will do that. Okay, well, things are not going like I thought, like it was yesterday. You know, I might have this backwards. I need to have the 9.9 over here and the 3.5 over here, so I'm stepping down, not stepping up. I bet you that's it. But right now I have 332 volts DC coming out of here. And that's, I was having 15 volts or so yesterday, so I gotta switch this transformer around. Hopefully that'll get it back to how it was yesterday. Okay, hold on one moment. Okay, I switched the transformer around, so now I'm stepping down. Now coming out of the full wave bridge rectifier is 300 milliamps going into this battery. There's 90 milliamps now and 120 volts feeding the rotovertor. Okay, that's the input. And again, I have the 9.9 on this side. This is in series on the run cap phase on L2, and this it's being stepped down in voltage now. And what I saw was 50 volts DC coming out of this voltage full wave bridge rectifier. So where's the other one? Let's see what it is. Oh, interesting. Okay, so with it connected, over here is 13 volts now, it says. With the battery connected, if I take off the battery, this is the same thing. It's got 310 milliamps feeding this battery. And you could say it's 13 volts because it's 13 volts right now across the DC side of the full wave bridge. If I take this battery off, it goes up to 50. See that? Interesting. So, you could say, I don't know what you could say. So, the battery's getting a charge. It's drawing too much now. Yesterday it was drawing 50 and putting out 80 milliamps, but it's putting out a lot more juice into the battery now. Huh. Okay. So I'm going to try and loop it now with a little statpower inverter. I probably could blow it up if these get disconnected and it shoots in 50 volts in there. But right now, as long as these are tight, I think it'll be okay. So one moment. Alrighty. The red and the green wire go to the input of the statpower inverter, positive on positive, negative on negative. The statpower inverter is on, and I don't see any smoke. So what I'm going to do now is quickly pull this out from the grid and quickly stick it in there, trying to give the motor no chance to drop in RPM and slip out of its sine wave. And also I know from experience that I'm going to need the run cap to be 2 UF for this stat power to latch to this motor at going 1800 RPM. I don't know why, it just is. So I'm going to disconnect this. Now it's running on only 2 UF. And look what I do when it's at 2 UF. Now I have 12.7 and then only 120 going in, but whatever, that doesn't matter. Okay, so here we go. After I get the stat power in and I got it looped with the battery running this, battery being charged is going to run this, and so it's looped. And now, after that, I'll add the 3.5 US. Okay, so I have to do this with the phone off, so just one moment. Okay, nice. I did it first try. If I didn't know it had to be 2 UF, this would be very frustrating. I'd probably give up. But I know this has to be 2 UF, the run cap. Now what happened, we have not so much going into the battery. We have 12.5 volts across the DC side of the full-way bridge, so that's 12.5 volts across here. The draw didn't go up or down. Now I'm going to plug this in and give it the right run cap side. Okay. Now we got a lot more juice going into the battery. Here's what the voltage is across the battery. And I still have that 90 milliamps over here. But it is now looped. Again, in my last video I was saying I was going to keep this a mystery. What is the amperage coming out of here, going into here? Oh, the draw was going down a little bit. I see the voltage dropped from 0.5 to 0.4. You know, I'm going to call it good here. What I want to do next is, this went down. Yesterday it was 50 milliamps going in. Only 90 milliamps going in here. I think this is working better than yesterday. So I'm stepping down. I really don't know what the heck I did different to make it as it is different. But it seems better. Now, what I'd like to do is up here, I'll show you 1 minute. Look at these. Dan Wood, who lives over in Switzerland, sent me these as a gift to make a looper or whatever I want. So I got 3 of these. 500 farads. Not sure exactly. Okay, it's got 6, 2.7, 2.7, 2. It comes to 16 volts, I believe, is the maximum these can do. And each one's 500 farads, so divide by 6 because they're in series, and it's like whatever it is, 90 farads or something. Pretty cool. So these are going to go in parallel to that battery. And I'm afraid of blowing these up, just like I've been afraid of blowing up that statpower inverter. So I don't want to do this right now. Okay, so I think that's good enough. Let's see what's going on over here. The voltage dropped. The inverter's still working. I don't know. Do I hear something? I don't know if this is better than yesterday. Maybe when this gets to 12 it'll stabilize. I don't know. I hear the statpower making a buzzer. So let's call it good before I destroy something. Okay. Thanks for watching.